Alright guys, we are going to talk about multiplying and dividing rational expressions. Now our notes have three sets of steps. We have steps for simplifying rational expressions, for multiplying rational expressions, and for dividing rational expressions. And that's sort of a three-tiered process. Simplification, we simplify. To multiply rational expressions, we will multiply and then simplify, and then when we divide, we just add another layer on top of that. But we'll start by simplifying, which means there won't be any multiplication or division. Go ahead and pause the video right here and copy down these steps on your paper. And when you're done copying them, unpause and we will go through them. All right, guys, so to simplify rational expressions, the way we do this is we first factor everything. You want to factor completely as you can factor. You need to factor. After you have factored everything, you're going to cross out common factors, things that are the same in the top and the bottom. And remember that they have to be exactly the same, After you've crossed out those common factors, you're going to rewrite the expression without the common factors. So you're going to make it look, as simple as possible, no common factors. And after you do that, you're going to walk away. Just leave it alone. Don't do any more multiplication, just walk away. Leave it as simplified as you can. Now, when you're multiplying, the first thing you're going to do is factor everything. And then you're going to take your two expressions and you're going to smoosh them together. And so that's what that means is you're going to just write everything together, side by side, in one big fraction. That's a Kurdish word, smoosh. If you want to pause the video and practice the word right now, it's a good time to do it. Again, the word is smoosh, and you're going to just shove everything together into one big fraction. After you've done that, you've got a whole bunch of factors all in one big fraction. You cross out common factors. So things that are the same in the top and the bottom, we're going to cross those out. And then we're going to rewrite the fraction without those common factors so it's simple. And then walk away. Just walk away at that point. Don't try to do any multiplication. Don't try to make anything, multiply anything out or make it look more simplified. Just walk away, leave everything factored. All right, so that's multiplication. Now, if you're dividing, what you do is you flip the second fraction and change the division sign to multiplication. That's the first thing we do. And after we do that, we're going to factor everything. Then we're going to smoosh, which again is writing it all together in one big fraction. Cross out common factors. Rewrite it without those common factors so it's simplified, and walk away. All right, so the first two examples I'm going to do are just simplification. See, it says simplify. Just simplification. There's no multiplication or division here. And so remember, to simplify, we just factor and cross out common factors. So looking at number 1, we don't even have to factor. It's already been factored for us. So I'm looking for common factors, and I see that I have an x minus 3 in the top and the bottom. And so remember, it has to be in the top and the bottom for us to cancel it out. But there it is. We cross them out, and then we rewrite. And so this is x plus 1 over x minus 2. And that's your answer. Walk away. That's our answer right there. Again, we didn't have to factor here because it was given to us in factored form. But this is our simplified fraction. We're done. We're going to walk away. All right, for number 2, I'm looking at this and I see a 3x on the top and a 3x on the bottom. Stop. This 3x is attached to the 6. We can't cross those out. Don't do it. Don't do it. What we can do is we can look at this 3x minus 6 and we can say, you know what? That 3 and that 6 both have a 3 in common. And so we can rewrite this as 3x over 3 times. And if I take 3 out of 3x, I'm left with x. And if I take 3 out of 6, I'm left with 2. And so that, I've now factored that. That x is attached to the 2. I can't cancel it out because it's attached to the 2. But what I can cancel out are the 3's. Now the 3's can both go away. And so I end up with x over x minus 2. And we have to leave it there. Again, these x's cannot cancel out because this x is attached to the 2. This is one piece right here. That minus 2 means that that x and that 2 are attached. We can't cancel either one of those things out. Not one without the other. And so we leave it like this. That's our answer. All right, looking at number 3, now we've got some factoring to do. Remember, this is a special factor pattern. It factors to x plus 3 and x minus 3. And then this, x squared plus 5x plus 6. Remember, we're looking for two numbers that multiply to 6 and add to positive 5. And those numbers are x plus 3 and x plus 2. And so then I look for common factors. Do I have anything that's the same in the top and the bottom? And here I have an x plus 3 here and here. So I cross those out. And then I rewrite this without that common factor. So it's x minus 3 over x plus 2. And that's my solution. And we walk away. Again, these x's cannot be canceled because this x is attached to the 3 and this x is attached to the 2, and I can't get rid of one without the other. All right, guys. And we're looking at this right here. Again, I'm looking for two numbers that multiply to -8 and add to -2. Those numbers are x minus 4 and x plus 2. And then I'm looking for two numbers that add or multiply to 10 and add to 7. And that's x plus 2 and x plus 5. So I'm looking for something that's the same on the top and the bottom. And here it's an x plus 2. I cross those out. And what I'm left with is x minus 4 over x plus 5. And that's as simple as it gets. It's as simple as it gets. We walk away. All right, number 5 is sort of a reminder of what we've just finished doing with exponents. Remember that you tackle these problems one piece at a time, right? So this is 15 over 5 times x over x times y squared over y times z cubed over z. It's a 3. 15 over 5 is 3. X over x is 1. This is y. Y squared divided by y is y. And this is z squared. So this is 3yz squared. And remember, that's something we did with exponents, properties of exponents. It's just a reminder there. So that's simplification. Now let's talk about multiplication. Remember, with multiplication, what we do is we factor everything. Then we smoosh, cancel out common factors, and rewrite. So right here, this guy right here does not need to be factored. This has already been factored for us. So we don't have to do that factor step. What we're going to do is we're going to smoosh. So I'm just going to write it all together as one fraction. So this is 3x, x plus 3, x minus 6 over x plus 3, x minus 6, x, and x minus 1. And so what I've done is I've just taken those two fractions and I've written them as one giant fraction. Okay, and now what I can do is I can cross out common factors, so things they have in common. So I've got an x plus 3 in the top and the bottom. I'm going to cross those out. And I've got an x minus 6 in the top and the bottom. I'm going to cross those out. And then I have this lonely x right here and this lonely x right there. They can both go. And then we write what is left in the top and what is left in the bottom. Well, what's left in the top is a 3, and what's left in the bottom is an x minus 1, like that. And so this is our simplified fraction is 3 over x minus 1. Now remember, if everything had canceled out in the top, you would have a 1 left in the top, but it didn't. There was a 3 there and it didn't cancel. So, all right guys, looking at this one right here, we factor everything completely, we smoosh, and then we cross out common factors and rewrite it. So, looking here, I've got an x squared plus 3x. There is no c value. There's nothing for me to point to and say I need to multiply this and add to this. There's none of that. And so what you do is you look at this and you say, okay, do these two pieces have anything in common, x squared and 3x? And the answer is yes. They both have an x. And so I say, okay, well that's x, and I pull that out of x squared and 3x, this becomes x plus 3. And again, the reason I did that is that it does not have a c value. It does not have a c value. So there was nothing for me to say, well, multiply to this and add to 3. So what we do is we just look for a common factor. All right, on the bottom, I'm looking for two numbers that multiply to 2 and add to negative 3. So multiply to positive 2 and add to negative 3. And those numbers are x minus 2 and x minus 1. That's that bottom factor. Here I'm looking for two numbers that multiply to negative 2 and add to negative 1. And so that's x minus 2 and x plus 1. And here I'm looking for numbers that multiply to 3 and add to 4. And so here that's x plus 3 and x plus 1. And so I factored all 4 of those pieces. And now what I do is I smoosh, so I put them all together. So this is x times x plus 3 times x minus 2 times x plus 1. We just throw it all together in the numerator and then throw everything together in the denominator as well. So x minus 2, x minus 1, x plus 3, and x plus 1. And then we look for common factors, things that are common to the top and bottom. X plus 1, cancel those out. I've got an x plus 3 here and here, so I cancel those out. And x minus 2 here and here, so I cancel those out. And all I'm left with is this x in the top and the x minus 1 in the bottom. And so that's our answer, is x over x minus 1. And remember that you cannot cancel out these x's. These x's cannot be canceled out because this x is tied to the 1. So you cannot cancel them out. You cannot cancel them out. There we go. All right, guys. Number 8 is, again, just a reminder of what we've just finished with exponents. The way I would do this is I would do the division on both of those first and then just put them together. This is not like these rational expressions where you factor or anything. No, just simplify. So 27 over 8, and the x's cancel. So this is 27 over 8 times x over x times y over 1, right? Because there isn't another y. And then times the 4 over 3 times x squared over x times 1 over y cubed. Okay, so this is 27 over 8 times 1 times y times 4 over 3 times x times 1 over y cubed. You know, again, put the things together that go together. So 27 over 8 times 4 over 3. That 1 just sort of disappears. This is y times 1 over y cubed, and then times x. It's just sort of chilling on its own there. 27 times 4 is 108. And 3 times 8 is 24. You know, this is times the y over y cubed, and then times x. 108 over 24, those are both divisible by 4 for starters. So if we divide by 4 here, this is 27 over, and 24 divided by 4 is 6. And then the y over y cubed, that's a y squared in the bottom. And the x goes in the top, like that. 27 and 6 are also both divisible by 3. So if you divide 27 by 3, you get 9x over, and 6 divided by 3 is 2y squared. Like that. And again, remember, this is just a reminder of the stuff we were doing before with exponents. All right, guys, the last couple of problems are division. And again, with division, what you do is you flip the second fraction and then proceed like it's multiplication. So that's the first thing I'm going to do is I'm going to flip. So this becomes x squared minus 5x plus 6 over x squared minus 8x plus 12. I am multiplying and I'm going to flip. So times x squared minus 6x. And then x squared plus x minus 12. And remember that rhyme, the dividing fractions is easy as pie, just flip the second and multiply. That's what we are doing here. We are flipping that second fraction and we're multiplying. So I flipped it, right? The denominator became the numerator and numerator became the denominator. And my division sign became a multiplication sign. Now that I've done that, I can do my factoring, which is the next step. So factor everything completely. So this is x squared minus 5x plus 6. I'm looking for numbers that multiply to positive 6 but add to negative 5. This is x minus 2 and x minus 3. Looking for numbers that multiply to 12 but add to negative 8. So that is x minus 6 and x minus 2. And then, again, this is not a trinomial, so I can't look for that c value. So instead what I do is I say, does x squared and 6x, do they have anything in common? And the answer is yes, they have an x in common. And I get x minus 6. And then things that multiply to negative 12 but add to positive 1x. That's an x plus 4 and an x minus 3. And now that everything is factored, we smeesh. So this is x minus 2, x minus 3, x and x minus 6 over x minus 6, x minus 2, x plus 4, and x minus 3. And once you've done that, we wrote it all as one big old fraction. Now you cancel out common factors. So here's x minus 2 is in the top and bottom, I cancel those out. X minus 3 is in the top and bottom, we cancel those out. X minus 6 is in the top and bottom, we cancel this out. And you'll see that what's left here is there's this lonely little x right there. And then x plus 4, like that. And remember, you cannot cross out these x's because this x on the bottom is tied to the 4. So it must stay with the 4. We can't cross them out. So this is your simplified rational expression. Walk away. All right, guys, last, and again, this is just a reminder of what we've been doing with exponents. Remember that you flip the second one and multiply. So 4xyz over 8x to the 4th, and then times 2x cubed y over 4x squared y squared z. So I flip the second fraction, and now I'm multiplying, right? Dividing by fractions is easy as pie. Flip the second and multiply. I would do what we did up here, which is I'd simplify each fraction first and then put them together. So 4 over 8 times x over x to the 4th times z times 2 over 4 times x to the 3rd over x squared times y over y squared times 1 over z. When you put those together, this is 1/2 times 1 over x cubed times z over 1, and then times 1/2 times x over 1, because there's an x cubed over an x squared, times 1 over y times 1 over z. Oh guys, I forgot my y right here. There's a y in addition to the z, so times y right there, right there. This y right here, I left it off. Like that. All right, put them together. 1/2 times 1/2. Those 1/2s I've put together now, right? Times 1 over x cubed. Took care of that one. There's that one times x over 1, right? So I put those together. Times, we'll do the y's next, so y over 1, which is that one right there, times 1 over y, which is that one right there. And then the z's, times z over 1 times 1 over z, like that. Okay. And so when you do this, guys, This becomes 1 over 4. There's an x here and an x cubed there. That's 1 over x squared. These y's cancel out, right? It's y over 1 times 1 over y, right? So y over y times z over z. So those are 1. And you get 1 over 4x squared. And that's your answer right there. And again, remember, this is a throwback to the exponent properties. Throwback to the exponent properties. All right, kiddos. That's simplifying, multiplying, and dividing rational expressions. Your assignment for today is a worksheet. Make sure that you get it finished. Come talk to me if you have questions.